Okay, geometry students, today we're going to talk about tangents. A tangent line intersects a circle at exactly one point called the point of tangency. So point A there on our graph is our point of tangency. A line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. Okay, perpendicular, if you remember correctly, creates a 90-degree angle right there from our radius to that line AB. Okay, keeping that in mind, we are going to check to see if AB is a tangent to circle P. So here we have our AB, and we're going to check to see, does this create the 90-degree angle that we need it to? Now this becomes a 90-degree triangle, and we remember that A squared plus B squared equals C squared. So we're going to say 8 squared plus 15 squared should equal 17 squared if this is a true tangent to this circle. 8 squared plus 15 squared is 289, and 17 squared is also 289. So yes, that is a true statement. So yes, line AB is tangent to circle P. All right, let's check number 2. We have our line AB, and we need to check to see, does it create a 90-degree angle with that radius AP? Again, we're going to do A squared plus B squared equals C squared. So 11 squared plus 14 squared should equal, well, they only gave us part of this hypotenuse, but we know from here to here is 11. So 5 plus 11 gives us 16 squared. So 11 squared plus 14 squared gives us 317, and 16 squared gives us 256. So we can see that 317 does not equal 256. So no, line AB is not a tangent to the circle P. Okay, let's take a look at number 3. If JK is tangent to circle L, find X. So they're telling us that JK is an actual tangent, so that creates a 90-degree angle there. So we're going to find X. Well, we've created a 90-degree triangle, so we can say A squared plus B squared equals C squared. So 7 squared plus 19 squared is going to give us our X squared, and that's what we need to solve for. 7 squared plus 19 squared gives us 410. And again, we're going to take the square root of both sides. The square root of 410 gives me 20.2, and that's going to be what X is equal to. Okay? Why don't you guys try number 4, pause your video, and then come back and check your answer. Okay, so you should have gotten 14.2 for number 4. Make sure that if you're not given part of your line, that you add in our radius there. If you missed that one, that's probably what you did. Let's take a look at number 5. For number 5, they give us this part of our what would be our hypotenuse, but we need to use the whole thing, and then we'll use that to figure out what our X is equal to. So let's call that whole hypotenuse Y. And we'll do 24 squared plus 10 squared. That's going to give me Y squared. Okay? So 24 squared plus 10 squared gives me 676. And then I'm going to take the square root of both sides to get rid of that squared. And I have 26 equals Y. Okay, but they ask us to find X. So we know from here to here, put it in red, from here to here is going to be 10. So my X is going to be equal to 26 minus 10, which is going to give me 16. Okay, I want you to do number 6, find X, and put that in your Ed puzzle. All right, let's turn the page. Skip 7, 8, and 9. Let's look at the more tangent properties here. So if two segments from the same external point are tangent to a circle, two segments from the same external point are tangent to the circle, so these two segments, and we know they're tangent these 90-degree angles here and here, then they are congruent. So that means that these two lines are going to be congruent to each other. AB is congruent to CB. Over here, if a polygon is circumscribed around a circle, then all sides are tangent. So if a polygon is circumscribed around the circle, then all of the sides are tangent. So that means this here, that's going to be a 90-degree angle. 90-degree here, 90-degree here, 90-degree here. So that means that these points, these separate segments, those are all going to be equal to each other. So I know that BD is going to be congruent to BE. I know that CE is going to be congruent to CF, and I know that AF is going to be congruent to AD. Okay? Let's take a look at number 10. They want us to find X. Assume that the segments appear to be tangent, that are tangent. Okay, so these are tangent, which creates 90-degree angles here. So that means that these two are going to be equal to each other. 5x plus 23 equals 8x minus 19. And we can solve. Subtract 5x from both sides. We get 23 equals 3x minus 19. Add 19 to both sides. And we get 42 equals 3x. Divide by 3. And we get x equals 14. Here's my solution. X equals 14. Okay, I'm going to have you guys try number 11 and answer an Ed puzzle. All right, let's skip number 12. Let's take a look at 13 and 14. So they want us to find the perimeter of the triangle DEF. So we're assuming, of course, that these are all tangent to the circle that it is surrounding, okay? And if we do that, then remember, these segments are going to be equal to each other. So this segment's going to be equal to that segment. This segment's going to be equal to this segment. And this segment should be equal to this segment, okay? So that means if this one is 16, then this guy is also 16. If that's 9.5, then this one is also 9.5. And if this is 11, then this guy is also 11. And we know to find the perimeter, we just add up all the sides. So we have the perimeter of triangle DEF equals 11 times 2 plus 16 times 2 plus 9. And that gives me 73. Okay, keeping that in mind, let's take a look at number 14. Again, we are going to assume that these are all tangent to the point where they touch the circle. All right, so that means that this segment and this segment are going to be the same. This segment and this segment are going to be the same. Let me do it in a different color. This segment and this segment. This segment and this segment are going to be the same. And then we have this segment and this segment. So if this segment is 23, then this segment is also going to be 23. Knowing that is going to help me figure out what my blue segments are going to be. So we do 37.5 minus 23, and that's going to get me 14.5. So the blue segments are both 14.5. Now, the green segment is 27.1, so that means this one is also 27.1. And that will help me figure out what the red segments are. So for the red segments, I'm going to do 52.5 minus 27.1. And that gives me 25.4. So this segment is 25.4. Okay, knowing all that, we can take all these numbers, we can combine them to figure out what the perimeter of our quadrilateral is. So the perimeter of our quadrilateral PQRS is going to be 2 times 23 plus 2 times 14.5 plus 2 times 27.1 plus 2 times 25.4. And when I add those all together, I get 180. So the perimeter of that quadrilateral PQRS is 180. All right, that's it. Enjoy.